And now in this lecture we'll answer on two questions. In the first question we'll find out the length of this standard MF is equals to x, and in the second question we'll find out the length of this standard AP that is also equals to x. So let's start with the first question. In the drawing we have three identical circles, and we also have here the big tangent ABC. The big tangent ABC is tangent to this circle at this point, point A, and it is tangent to the middle circle at this point, point B, and it is also tangent to this circle at point C. In addition, we have the common start point, point M. From this common start point, point M, we have tangent ME, that is tangent to this circle at point E. We have also tangent MD, that is tangent to this circle at point D. The length of tangent MD is 5 units. Again, we have tangent ME, that is tangent to this circle at point E. The length of tangent ME is 7 units. And finally, we have also tangent MF, that is tangent to this circle at point F. The length of tangent MF is x, and our mission is to find out the value of x. So first of all, we define the center of this circle, this point as point P. We define the center of this circle, the middle circle, this point is point Q. And finally, we define the center of this circle as point S. In the next step, we will join points P and D together by a straight line. MD is tangent to the circle at point D. So we join points P and D together by a straight line. Point P is the center of this circle, point D is the point of the circle itself, therefore PD is the radius of this circle. We define the radius of this circle as R, and because of the fact that those three circles are identical, they will have also the same radii. That is to say, the radius of this circle is R, and the radius of this circle is also R. And because of the fact that the radius PD of this circle, the radius PD is equal to R, the radius PD is drawn to point D, that is the point of tendency of tangent MD in this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this angle equals to 90 degrees according to rule 1. In the next step, we will join points M and P together by a straight line. By joining points M and P, we created the right triangle, triangle MPD. So, in the next step, we will implement the Pythagoras theorem on this right triangle, triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MPD is MP, therefore the square of the hypotenuse is MP squared, and it is equal to PD squared plus MD squared. And again, according to the Pythagoras theorem, in the right triangle, triangle MPD, MD squared equals to PD squared plus MD squared. Again, MP squared equals to PD squared plus MD squared. MP, the opposite MP is the missing side, so we leave it as it is, so it is again, MP is the missing side, so we leave it as it is, so it is MP squared equals to PD squared. PD is R, therefore PD squared is R squared plus MD squared. MD equals to 5 units in its length, therefore MD squared is 5 squared, that is 25. So in total, according to equation 1, we should find out that MP square equals to R square plus 25. We'll repeat on the same process on this middle triangle. That is to say, we join points Q and E together by a straight line. QE is of course the radius of this circle, that is equals to R. Again, because of the fact that the radius QE is drawn to point E, that is point of tendency of tangent ME with this circle, and whenever you have radius that is drawn to the point of tendency, then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that this angle equals to 90 degrees according to rule 1. So in the next step, we join points M and Q together by a straight line. By joining points M and Q, we can do the right triangle, MQE. So in the next step, we'll implement the Pythagoras theorem on this right triangle, MQE. On this right triangle, MQE, MQ squared, that is the square of the hypotenuse, is equal to QE squared plus ME squared. Okay, again, according to the Pythagoras theorem in the right triangle MQE, MQ squared, that is the square of the hypotenuse, equals to QE squared plus ME squared. MQ is the missing side, so leave it as it is, so it is MQ squared equals to QE squared. QE is the radius of this circle, that is R, therefore QE squared is R squared plus ME squared. ME is 7, therefore ME squared is 7 squared, it is 49. So in total, according to equation 1, we should find out that MQ squared equals to R squared plus 49. And finally, we repeat on the same process on this right circle. That is to say, we join points we join point S and F together by a straight line. SF is of course the radius of this circle, that is equal to R. Again, because of the fact that the radius SF is drawn to point F, that is the point of tendency of tangent MF in this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent MF will be perpendicular to the radius Fs. If MF perpendicular to Fs, it means this angle equals to 90 degrees in its side. In the next step, we join points S and M together by a straight line. By joining points S and M, we can then here the right triangle, MFS. So in the next step, we will implement the Pythagoras theorem on this right triangle, MFS. According to the Pythagoras theorem, in this right triangle MFS, MS squared, that is the square of the hypotenuse, equals to SF squared plus MF squared. Okay, again, according to the Pythagoras theorem, in this right triangle MFS, MS squared, that is the square of the hypotenuse, equals to SF squared plus MF squared. MS is the missing side, so we leave it as it is. So it is MS squared equals to SF squared. SF is R, therefore SF squared is R squared plus MF squared. MF is X, therefore MF squared is X squared. MF is the tangent that we are looking for in this question. So in total, according to equation 3, we should find out that mn squared equals to r squared plus x squared. In the next step, we'll join points P and A together by a straight line. PA is of course the radius of this circle is equal to r, and because of the fact that the radius PA is drawn to point A, that is the point of tendency of tangent ABC with this circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius AP. If ABC is perpendicular to AP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. Likewise, we join points Q and B together by a straight line. QB is of course the radius of this circle that is equal to r, and because of the fact that the radius QB is drawn to point B, that is the point of tendency of tangent ABC with this circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius BQ. If ABC is perpendicular to BQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. Likewise, we join points S and C together by a straight line. SC is of course the radius of this circle that is equal to r. Again, because of the fact that the radius SC that is equal to r, the radius SC is drawn to point C, that is the point of tendency of tangent ABC with this circle, and whenever your radius is drawn to the point of tendency, then tangent ABC will be perpendicular to the radius CS. If ABC is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. Actually, we know that the distance of those 3 points P, Q, and S from the straight line ABC is equal to r. So they have the same distance, those 3 points P, Q, and S that are the centers of those 3 circles. So those 3 points have the same distance from the straight line ABC, and the distance of these 3 points P, Q, and S from the straight line ABC is r. And for that reason, all those 3 points P, Q, and S must be located on the same straight line. That is to say, PQS is one straight line. So PQS is one straight line. And again, PQS is one straight line because of the fact that the 3 points P, Q, and S are located in the same distance from the straight line ABC. And exactly for the same reason that the 3 points P, Q, and S are located in the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. Again, because of the fact that the 3 points P, Q, and S are located at the same distance from the straight line ABC, therefore the straight line PQS must be parallel to the straight line ABC. And therefore, here we can implement rule 17. So, repeat quickly on rule 17. According to rule 17, the sum of one-sided interior angles that are located between 2 parallel lines is equal to 180 degrees. So in the drawing we have line A that is parallel to line B. The red line is line C. Line C cuts the 2 lines A and B at those 2 points. That is the way it intersects with those two lines A and B, those 2 points, and we also have here those 2 angles alpha and beta. Those 2 angles alpha and beta are defined as one-sided angles. Why? Because of the fact that those 2 angles alpha and beta, they are both located on the left side of the red line C. For that reason, they are defined as one-sided angles. And because of the fact that those 2 angles alpha and beta, they are both located between the parallel lines A and B, they are also defined as an interior angles. So in total, those 2 angles alpha and beta, they are defined as one-sided interior angles. And according to this rule 2, rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. That is to say, angle alpha plus angle beta is equal to 180 degrees according to this rule 17. Again, according to rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. Those 2 angles 1 and 2, they are also defined as one-sided interior angles, and therefore the sum of those 2 angles is equal to 180 degrees according to this rule of 17. That is to say, angle 1 plus angle 2 is equal to 180 degrees according to this rule of 17. So we can actually implement rule 17 in our drawing. Why? Because in our drawing we have those 2 angles that are defined as one-sided interior angles, and according to rule 17, the sum of 2 one-sided interior angles is equal to 180 degrees. Therefore, the sum of those 2 angles must be equal to 180 degrees. This is a right angle, that is to say it is equal to 90 degrees in its size. So this angle plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles, they are also defined as one-sided interior angles, and the sum of those 2 angles must be equal to 180 degrees according to rule 17. So 90 degrees plus this missing angle, in total must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. Likewise, those 2 angles, they are also defined as one-sided interior angles, and according to rule 17, the sum of those 2 one-sided interior angles is equal to 180 degrees. So this angle equals to 90 degrees, plus this missing angle, in total the sum of those 2 angles must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. And finally, those 2 angles are also defined as one-sided interior angles. This angle equals to 90 degrees. So this angle that is 90 degrees plus this missing angle, in total must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size, according to rule 17 of course. So in total, inside quadrilateral PQBA, inside this quadrilateral we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a tesseract angle if not a square. So we relate to this quadrilateral PQBA, it's a rectangle because it has 4 right angles. So I write it down. This is quadrilateral PQBA, and it is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQBA, side AB must be equal to the opposite side PQ. But AB is 3 units in its length, therefore the opposite side PQ must be also equal to 3 units in its length. Likewise, inside quadrilateral QSCB, inside this quadrilateral we have 4 right angles, and according to rule 5, this quadrilateral must be a tesseract angle if not a square. So relate to this quadrilateral QSCB is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle QSCB, side BC must be equal to the opposite side QS. But BC is 3, therefore the opposite side QS must be also equal to 3 units in its length. In the next step, I'll copy triangle PMS, this big triangle PMS in the Olympiad, we will analyze this big triangle PMS. Here we have line segment MQ, actually that bisect side PS of this triangle PMS, and this line segment MQ is defined as a median of this triangle PMS. The median is a line segment that starts from the vertex of the triangle and ends at the midpoint of the opposite side PS. Point Q is at the midpoint of the opposite side PS. Why point Q is at the midpoint of PS? Because in total PS equals to 3 plus 3, that is 6, and point Q actually bisects side PS. That is to say, it divides side PS into two halves. Each half equals to 6 over 2, that is 3. Okay, so line segment MQ is defined as a median of this triangle PMS. Again, a median, it is a line segment that starts from the vertex of a triangle and ends at the midpoint of the opposite side. The opposite side of the vertex. The opposite side of vertex M is PS, and it actually ends at the midpoint of PS. That is to say, point Q, that is a midpoint of PS. So in the next step, I'll copy the right triangle PMS in the page, and we will analyze this big triangle PMS. Again, actually, this is triangle MPS, as I call it from the original drawing. The red line segment MQ is the median of this triangle PMS. So write it down. Again, a median of a triangle is defined as a line segment that from the vertex of the triangle to the midpoint of the opposite side. And the median bisects the opposite side. The median MQ bisects the opposite side PS. That is to say, it divides side PS into two halves. In total, PS equals to 3 plus 3, that is 6. So the median MQ bisects side PS into two halves. The first half is PQ, that is equals to 3 units in its length, and the second half is QS, that is also equals to 3 units in its length. But what is the length of the median MQ? Actually, we have a special formula for a median, the length of the median of a triangle. So, in the drawing, we have triangle ABC. This is triangle ABC. Side AB equals to B units in its length, side AC equals to C units in its length, and this is side BC, that is equals to A units in its length. Line segment AD is the median of this triangle ABC. Why? Because of the fact that it starts from vertex A of this triangle and ends at the midpoint of BC. That is to say, it ends at point D, that is the midpoint of side BC. Why point D is the midpoint of side BC? Because of the fact that at point D, side BC has been sectioned into two halves. The first half is BD, and the second half is DC. So BD equals to DC. So AD is the median of this triangle ABC. But what is the length of the median AD? Actually, according to the new formula, the length of the median AD is equals to the square root of 2b squared plus 2c squared minus a squared over 2. Again, the length of the median AD is equal to the square root of 2b squared plus 2c squared minus a squared over 2. Actually, you can implement the new formula in order to find out the length of the median AQ, this triangle MPS. According to the new formula, the length of the median MQ will be equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. It again, according to the new formula, the length of the median MQ is equal to the square root of 2 times MP squared plus 2 times MS squared minus PS squared divided by 2. Here we'll multiply this equation 1 by 2, and we get that according to equation 1, two times MQ equals to the square root of 2MP squared plus 2MS squared minus PS squared. Repeat again, after we multiply this equation 1 by 2, we shall find out that 2 times MQ equals to the square root of 2MP squared plus 2MS squared minus PS squared divided, actually multiplied by 2, so it is not divided by 2. Okay, so in total 2 times MQ equals to the square root of 2MP squared plus 2MS squared minus PS squared. So here we'll square both sides of this equation. What is the value of 2 times MQ squared? Actually it is 2 squared, it is 4 times MQ squared. So in total 2MQ squared is equal to 4 times MQ squared. So here we'll square this side of the equation 1. And actually the square cancels the root, and therefore we left only with what is inside this root. That is to say, we left only with 2 times MP squared plus 2 times MS squared minus PS squared. Actually, the square and the root are two opposite operations, and when you do the both operations simultaneously, one cancels the other one, and therefore we left only with the original expression. We have here square, we have here root. When we square the root, it will cancel the root, and we left only with 2MP squared plus 2MS squared minus PS squared. So according to equation 1, 4 times MQ squared mq square equals to r square plus 49. Therefore, we substitute mq square here by r square plus 49, and it is equals to 2 times mp square. mp square according to equation 1 is r square plus 25. Therefore, we substitute mp square here by r square plus 25 plus 2 times ms square, of course, here. So 2 times ms square. ms square according to equation 3 is r square plus x square. Therefore, we substitute ms square here by r square plus x square. And we have also here minus ps square. So ps, this is side ps, that is in total it is equals to 3 plus 3, that is 6. So ps equals to 6, therefore ps square is 6 squared, that is 36. So minus ps square is minus 36. Here we'll open the brackets on both sides of this equation, equation 1. And you get that according to this equation, equation 1, 4 times r squared. Here also 4 times 49 is 196, so it is plus 196. That is equals to 2 times r squared plus 2 times 25 is 50, so it is plus 50, plus 2r squared plus 2x squared minus 36. So we have 4r squared in this side of this equation 1, and we have 2r squared plus 2r squared on the other side. That is actually, of course, 4r squared. So we will cancel 4r squared from both sides of this equation. So here 4r squared is cancelled, and 2r squared plus 2r squared is also 4r squared, so they will be also cancelled. So in total, after we cancel 4r squared, in the side of equation 1 we have to only with 196. On the other side of this equation 1 we have 50 minus 36 is 14 plus 2x squared. So in total, according to equation 1, we can find out that 196 equals to 14 plus 2x squared. Here we subtract 14 from this equation, equation 1, and finally we get that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divide this equation, equation 1 by 2, and finally we get that according to equation 1, 182 over 2 is 91, so 91 equals to x squared. So here we take a root out of this equation, and finally we get that x equals to the square root of 91. On terms of numbers, the square root of 91 is 9.54 units. And that is the answer to the question. Repeat again, I found out that the length of this tangent MF, that is equal to x, is equal to either the square root of 91 units, or in terms of numbers, MF that is equal to x is equal to 9.54 units. So I finish with the first question. And the next time I'll present to you the second question, and we solve the second question of this lecture. Our mission in this second question is to find out the length of tangent AP that is equals to x. We have to find out the value of x. So in the domain we have a quarter circle AOB. AOB is a quarter circle. Inside this quarter circle AOB we have this small circle. Actually the small circle touches the big quarter circle at this point. So we define the attachment point, this point is point K. In addition, you know that this is line segment OQ that is equals to 5 units in its length. Tangent AP is tangent to this small circle at point P, and the length of tangent AP is x, and our mission is to find out the value of x. In the first step, we define the center of this small circle. This point is point C. And we'll join point C and 2 together by straight line. CQ is of course the radius of this small circle. We'll define the radius of this small circle as A. Therefore, CQ equals to A units in its length according to our definition. We'll define the radius of this big quarter circle as B. So OB is the radius of this big quarter circle that is equals to B units in its length according to our definition. AO is also the radius of this quarter circle that is equal to B units in its length according to our definition. So CQ is the radius of this small circle that is equal to A units in its length. And because of the fact that the radius CQ is drawn to point Q, that is the point of tendency of tangent OB with this small circle, and whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius QC. If OB is perpendicular to QC, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we join point C and P together by straight line. AP is a tangent to this small circle at point P. PC is of course the radius of this small circle that is equal to A units in its length, and because of the fact that the radius CP is drawn to point P, that is the point of tendency of tangent AP with this small circle, whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PC. If AP is perpendicular to PC, it means that this angle equals to 90 degrees according to rule 1. In the next step, we join points A and C together by straight line. By joining points A and C, we create the right triangle APC. So in the next step, I'll copy the right triangle APC in a new page, and we'll implement the Pythagoras theorem on this right triangle APC. Here by PT is a version for Pythagoras theorem. So actually, this is the right triangle APC that I come from the original domain according to the Pythagoras theorem. In this right triangle APC, AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. So I'll write it down. This will be equation 1. AC squared, that is the square of the hypotenuse, is equal to AP squared plus PC squared. The hypotenuse AC is the missing side, so we leave it as it is. So it is AC squared equals to AP squared. AP is x, therefore AP squared is x squared. plus PC square. PC is 8, therefore PC square is A square. So in total, according to equation 1, we should find out that AC square equals to X square plus A square. So in the drawing, we have an internal arc between the small circle and the big quarter circle. That is to say, they touch each other internally in this point K. And whenever you have an internal arc between two circles, semicircles or quarter circles, you can implement rule 9. So I put quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. In the drawing, we have two circles. The center of this big circle is 0 at point O. The center of this small circle is 0 at point M. And the straight line that connects their centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass for their touching point, that is point P. Again, the straight line OM must pass for point P, that is their touching point. So OMP is one straight line. Again, OMP is one straight line according to this rule 9. So I can actually implement rule 9 in our drawing. In our drawing, we have an internal notch between the big quarter circle and the small circle. That is to say, they touch each other internally in point K. Therefore, we can implement here rule 9. According to rule 9, actually, the center of this quarter circle is 0 at point O. The center of this small circle is 0 at point C. And the straight line that connects their centers together is the straight line OC. And according to rule 9, the straight line OC must pass for their touching point, that is point K. Again, the straight line OC must pass for point K, that is their touching point. OCK is one straight line. Again, OCK is one straight line according to rule 9. So I join points O and C together by straight line. And according to rule 9, the straight line OC must pass for their touching point, that is point K. Or OCK is one straight line. So it is very easy to see that indeed the straight line OC passes from point K, that is their touching point. Or OCK is one straight line. What is the definition of line segment CK? It starts from point C, that is the center of this small circle, and then to point K, that is the point of the small circle itself. So this is exactly the definition of a radius. Therefore, CK is the radius of this small circle, that is equals to A units in its length, according to our definition. CK equals to A. What is the definition of line segment OK? Line segment OK starts from the center of this quarter circle, that is point O, and ends at point K, that is a point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, OK is the radius of this quarter circle, that is equals to B units in its length, according to our definition. What is the length of line segment OC? OC equals to OK minus CK. Again, OC equals to OK minus CK. So I write it down. OC equals to OK minus CK. So in total, OC equals to OK is B, this is the radius of the quarter circle, that is B, minus CK. CK is 8, is the radius of the small circle. So in total, OC equals to B minus A units in its length. This is line segment OC, that is equals to B minus A units in its length. In the next step, we will do a construction, that is to say, from this point C, that is the center of this small circle, we will do a perpendicular on AO. Again, from point C, we will do a perpendicular on AO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO, this point is point N. By doing this construction, you can do the quadrangle NCQO. Inside this quadrangle NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this four facing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this four facing angle must be equal to 90 degrees in its size. So inside quadrangle CNOQ, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be a rectangle and not a square. So relate to this quadrangle CNOQ is a rectangle because it has 4 right angles. So write it down. Quadrangle NCQO is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle NCQO, side OQ must be equal to the opposite side NC, but OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum rule, in the same rectangle NCQO, side CQ must be equal to the opposite side NO, but CQ is 8, therefore NO must be also equal to 8 units in its length. What is the length of the missing 97 AN? From the drawing, it is very easy to see that AN equals to AO minus NO. Again, AN equals to AO minus NO. So I write it down. AN equals to AO minus NO. So AN in total equals to AO. AO is the radius of the quarter circle, that is B, minus NO. NO equals to A. So in total, AN equals to B minus A units in its length. AN equals to B minus A units in its length. So in the next step, I'll copy the right triangle A and C in the new page, and we'll implement the Pythagoras theorem on this right triangle A and C. Side NC equals to 5 units in its length. Side AN equals to B minus A units. And AC, the opposite AC is the missing side. So here, by PT's evaluation for Pythagoras theorem, according to the Pythagoras theorem, on this right triangle A and C, AC squared, that is the square of the hypotenuse, is equal to AN squared plus NC squared. This will be equation 2. AC is the missing side, so leave it as it is. So it is AC squared equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared plus NC squared. NC is 5, therefore NC squared is 5 squared. that is 25. So in total, according to equation 2, we have found out that AC squared equals to B minus A squared plus 25. But according to equation 1, AC squared equals to X squared plus A squared. So we substitute AC squared here in this equation 2 by X squared plus A squared from equation 1. We do it now, we get that AC squared is X squared plus A squared, and it is equals to B minus A squared. B minus A squared equals to B squared plus A squared minus 2 times A times B plus 25. So here we have A squared on both sides of the equation, so A squared will get cancelled. After we cancel A squared, in this side of equation 2, we left only with X squared. On the other side of the equation 2, we have left with B squared minus 2AB plus 25. So in total, according to equation 2, we have found out that X squared equals to B squared minus 2AB plus 25. In the next step, we will implement the Pythagoras theorem on this right triangle OCQ. So I copy the right triangle OCQ in a new page, and we will implement the Pythagoras theorem on this right triangle OCQ. We have already found out that side OC of this right triangle OC equals to B minus A units in its length. That is to say, the hypotenuse of the right triangle OCQ is B minus A. Side CQ of the right triangle OCQ is A, it is the radius of the small circle. And finally, OQ equals to 5 units in itself, according to what is given as the question. Here by PT is a version for Pythagoras theorem. So for me, this is the right triangle OCQ that I go with congruent domain according to the Pythagoras theorem. In this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus OQ squared. So I write it down, this will be equation 3. OC squared, that is the square of the hypotenuse, is equal to CQ squared plus OQ squared. OC is B minus A, therefore OC squared is B minus A squared. And it is equal to CQ squared. CQ is A, therefore CQ squared is A squared plus OQ squared. OQ is 5, therefore OQ squared is 5 squared, that is 25. So in total, according to equation 3, we have found out that B minus A squared equals to A squared plus 25. So B minus A squared is B squared plus A squared minus 2 times A times B, and it is equal to A squared plus 25. So here we have A squared on both sides of this equation 3, so A squared will get cancelled. After cancelled A squared, on this side of the equation 3 we left with B squared minus 2 times AB, and on the other side of this equation 3 we left only with 25. So in total, according to equation 3, we have found out that B squared minus 2AB equals to 25. Now we can substitute b squared plus 2ab in this equation 2 by 25 from equation 3. We do it now, we get that according to equation 2, x squared equals to b squared plus 2ab is 25, and also plus 25. So in total we found out that x squared equals to 25 plus 25, that is 50. So x squared equals to 50. Here we take a hold of this equation and finally we get that x equals to the square root of 50. So x equals to 50 is 2 times 25. And the square root of 25 is 5. So in total this expression equals to 5 times square root of 2. 5 times square root of 2 is 7.071 units. And that is the answer to the question. So x that is the length of this 97 AP is equal to either 5 times square root of 2 units, or in terms of numbers it is equal to 7.071 units. Okay, again, we have found out that the length of this 97 AP is equal to x, it is equal to either 5 times square root of 2 units, or in terms of numbers, the length of this 97 AP is equal to x is equal to 7.071 units. Okay, so we finish with the second question. In the next episode of the lecture, we'll start with the first question, of course. Our mission in this first question is to find out the length of this tangent MF that is equals to x units in its length according to what is given in the question. We have to find out the value of x. So in the drawing we have 3 identical circles. In addition we have also the big tangent ABC, that is tangent to this circle at point A, it is tangent to this circle at point B, it is tangent to this circle at point C. In addition, we have here the common sub point M. From this common sub point M, we have tangent MD, that is tangent to this circle at point D, and the length of tangent MD is 5 units. In addition, we also have tangent ME, that is tangent to this circle at point E, and the length of tangent ME is 7 units. And finally, we have also tangent MF, that is tangent to this circle at point F, and the length of tangent MF is x. Okay, so our mission is to find out the length of tangent MF that is equal to x. We have to find out the value of x. So first of all, we define the center of this circle, this point as point P. We define the center of this middle circle as this point as point Q, and we define the center of this circle, this point as point S. In the next step, we join points P and D together by a straight line. PD is the radius of this circle that we define this now. And because of the fact that the radius PD is known to point D, that is the point of tendency of tangent MD with this circle, and whenever your radius that is known to the point of tendency, then tangent PD will be perpendicular. Then tangent MD will be perpendicular to the radius DP. If MD is perpendicular to DP, it means that this thing equals to 90 according to all 1. In the next step, we join points M and P together by straight line. By doing this construction, we can do the right triangle MPD. So in the next step, we implement the Pythagoras theorem of this right triangle MPD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse of this right triangle MPD is MP, therefore the square of the hypotenuse is MP squared. So MP squared must be equal to PD squared plus MD squared. So repeat again. According to the Pythagoras theorem and the right triangle MPD, MP square equals to PG square plus MD square. MP is the missing tangent, so leave it as it is, and it is equals to PD square. PD is R, therefore PD square is R square, plus MD square. MD is 5, therefore MD square is 5 square, that is 25. So in total, according to equation 1, we have found out that MP square equals to R square plus 25. We repeat it on the same process on this middle circle. That is to say, we join points Q and E together by straight line. QE is of course the radius of this circle, this is equals to 1, because of the fact that all three circles are identical. They have also the same radii. So the radius of this circle is also R. And because of the fact that the radius QE is drawn to point E, that is the point of tendency of tangent ME with this circle, and whenever you have radius that is drawn to the point of tendency, then tangent QE will be perpendicular. Then tangent ME will be perpendicular to the radius EQ. If ME is perpendicular to EQ, it means that the angle equals to 90 degrees according to rule 1. In the next step, we join points M and Q together by straight line. When doing this construction, we can identify the right triangle MEQ. So in the next step, we implemented the Pythagoras theorem on this right triangle MEQ. According to the Pythagoras theorem, MEQ, ME squared, that is the square of the hypotenuse, equals to EQ square plus QM square. Again, actually, the hypotenuse of this right triangle MEQ is MQ, for the square of the hypotenuse is MQ square, so MQ square equals to EQ square plus EM square. And again, according to the Pythagoras theorem, the right triangle MEQ, MQ square equals to QE square plus ME square. MQ is the missing sign, so we leave it as it is, so it is MQ square equals to QE square. QE is R, therefore QE square is R square, plus ME square. ME is 7, therefore ME square is 7 square, that is 49. So in total, according to equation 2, we found out that MQ square equals to QE square, MQ square equals to R square plus 49. Repeated on the same process on this triangle, that is to say, on this circle, that is to say, we join points F and S together by straight line. Fs is the radius of this circle, that is R, and according to rule 1, this angle equals to 90 degrees. In the next step, we join points M and S together by straight line, and we implemented the Pythagoras theorem on this right triangle MSF. According to the Pythagoras theorem, in this right triangle MSF, MS squared, that is the square of the hypotenuse, equals to Fs squared plus Fm squared. Repeat again, according to the Pythagoras theorem on the right triangle MFS, MS squared equals to SF squared plus MF squared. MF is the missing sign, so MS is the missing sign, so we leave it as it is, and it is equals to SF square. SF is R, therefore SF square is R square, plus MF square. MF is X, therefore MF square is X square. So in total, according to equation 5, we found out that MS square equals to R square plus X square. In the next step, we join points P and A together by straight line. PA is the radius of this circle, that is R, and according to 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points Q and B together by straight line. QB is the radius of this circle, that is R, and according to 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And finally, we join points S and C together by straight line. SC is also the radius of this circle, that is R, and according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Here we have the 3 points P, Q, and S. They are all at the same distance from the straight line ABC, and therefore those 3 points P, Q, and S must be located on one straight line. That is to say, PQS is one straight line. And exactly for the same reason that the 3 points P, Q, and S at the same distance from the straight line ABC, it means that the straight line PQS is parallel to the straight line ABC. So here you can implement rule 17. Repeat quickly on rule 17. Because of the fact that the straight line PQS is parallel to the straight line ABC, you can implement here rule 17. So let's make rule 17. According to rule 17, the sum of one-sided interangles that are located between two parallel lines is equal to 180 degrees. So in the moment we have line A that is parallel to line B, and line C intersects with the two lines A and B at those points, and we have also those two angles alpha and beta that are defined as one-sided interangles, and according to this rule 17, the sum of those two angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. We can implement rule 17 in our drawing. When put in our drawing, those two angles are defined as one-sided interangles. According to rule 17, the sum of those two angles must be equal to 180 degrees. So this angle equals to 90 degrees according to rule 1. So 90 degrees plus the size of this angle in total must be equal to 180 degrees according to rule 17. And therefore this missing angle must be equal to 90 degrees in its size. The same thing is true here. Those are one-sided interangles, and the sum of those two one-sided interangles is equal to 180 degrees. So this angle is a right angle plus this missing angle in total must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. The same thing is true here. The sum of those two angles is equal to 180 degrees according to rule 17. So this is the right angle plus this missing angle in total must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its size. And finally, the sum of those two angles must be also equal to 180 degrees because there are two one-sided interangles. But this is a right angle, so 90 degrees plus the size of this missing angle in total must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So in sine quadrangle PQBA, we have four right angles, and according to rule 5, any quadrangle that has four right angles must be this right angle in front of the square. So relate to this quadrangle PQBA is right angle because it has four right angles. But we also know that the opposite sides of right angle are equal to each other. So right angle PQBA, side AB must be equal to the opposite side PQ. But AB is free, therefore PQ must be also equal to 3 units in its length. Likewise, inside quadrangle QBCS we have four right angles, and therefore according to rule 5, this quadrangle QBCS is a right angle. But we also know that the opposite sides of right angle are equal to each other. So right angle QBCS side BC must be equal to the opposite side QS. But BC is free, therefore QS must be also equal to 3 units in its length. In the next step, I call it the big triangle MPS in an equation, and analyze this big triangle MPS. Okay. This is a triangle MPS that I call it from the original drawing. The red line MQ is the median of this triangle MPS. The median of a triangle is a line segment that starts from the vertex and ends at the midpoint of the opposite side of the vertex. In this case, the vertex is M and the opposite side of the vertex M is PS. So point Q is located at the midpoint of PS. That is to say, the median MQ bisects the opposite side PS. That is to say, it divides side PS into two halves. Each half equals to PS over 2. So PQ equals to SQ equals to PS over 2. In this case, PQ equals to 3 units in its length, and QS also equals to 3 units in its length because of the fact that the median MQ bisects both PS. PS in total is 6, and therefore each half must be equal to 3 units in its length. PQ equals to 3, and SQ also equals to 3 units in its length. But the question is, what is the length of the median MQ? We have a special formula for the length of the median of a triangle. Okay, according to the special formula, here we have triangle ABC, side AB equals to B units in its length, side AC equals to C units in its length, and side BC equals to A units in its length. AD is the median of this triangle ABC, that is to say, it starts from the vertex A and ends at point D, that is the midpoint of side BC. At point D, side BC has been bisected into two halves. Each half equals to BC over 2. The first half is BD, the second half is DC, and each half equals to BC over 2. And of course, BD equals to DC. So what is the length of this median AD? According to the new formula, the length of the median AD is equals to the square root of 2b squared plus 2c squared plus a squared over 2. So can actually implement the new formula in order to find out the length of the median MQ of this triangle MPS. According to the new formula, the length of the median MQ is equal to the square root of 2 times MP squared plus 2 times MS squared plus PS squared divided by 2. We multiply this equation, equation 1 by 2, and find that according to equation 1, 2 times MQ equals to the square root of 2MP squared plus 2MS squared plus PS squared. According to equation, we have 2 times, we squared both sides of this equation, equation 1, 2 times MQ squared is 4MQ squared, and the square cancels the root, and we left only with 2MP squared plus 2MS squared plus PS squared. So we have here 4MQ squared. According to equation 1, MQ, according to equation 2, MQ squared equals to R squared plus 49. Therefore, we substitute MQ squared here by R squared plus 49. And we have also equals to 2MP squared. MP squared according to equation 2, MP squared according to equation 1 is R squared plus 25. Therefore, we substitute MP squared here by R squared plus 25, and we have also 2 times MS squared. According to equation 3, MS squared is R squared plus X squared. Therefore, we substitute MS squared here by R squared plus X squared, and we have also minus PS squared. PS in total is 6, therefore PS squared is 6 squared, that is 36. So minus PS squared is minus 36. We open the brackets on both sides of the equation and found out that 4 times R squared plus 4 times 49 is 196, so it is plus 196 equals to 2R squared plus 2 times 25 is 50, so it is plus 50, and we have 2R squared plus 2x squared minus 36. So here we have 4R squared on both sides of the equation. Here we have 2R squared plus 2R squared, which is 4R squared. Here also we have 4R squared, so 4R squared we can cancel. After we cancel 4R squared, in this side of the equation we left only 196. On the other side of the equation we have 50 minus 36, that is 14. So in total on this side of the equation we have 14 plus 2x squared. So in total according to equation 1, we found out that 196 equals to 14 plus 2x squared. Here we subtracted 14 from this equation 1, and we found out that 196 minus 14 is 182, so 182 equals to 2x squared. Here we divided this equation 1 by 2, and finally found out that x squared equals to 182 over 2 is 182 over 2 is 91. So in total, x squared equals to 91. Here we took out of this equation, and finally found out that x equals to the square root of 91 units. So in terms of numbers, the square root of 91 is 9.54 units. So in total, we found out that the length of this tangent MF is equals to x. It is equals to either the square root of 91 units. So in terms of numbers, MF is equal to x is equal to 9.54 units. So finish with the first question. In the next step, I present to you the second question, and we solve the second question of this lecture. So, our mission in the second question is to find out the length of this tangent AP that is equal to x. So in the moment, we have a quarter circle, A or B is a quarter circle. Inside this quarter circle, we have this small circle. We also know that this is line segment OQ that is equal to 5 units in its length. This is tangent AP that is equal to x, and we have to find out the length of tangent AP that is equal to x. We have to find out the value of x. So first of all, we define the center of this circle. This point is point C. And then we join point C and Q together by straight line. CQ is the radius of this small circle. We define the radius of this small circle as A. And according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we join point C and P together by side line. CP is the radius of this small circle that is A, and according to rule 1, this angle equals to 90 degrees. In the next step, we join points A and C together by side line. In this way, we create the right triangle ACP. In the next step, by forming the right triangle ACP in the new page, and we implemented the Pythagoras theorem on this right triangle ACP. Actually, this is the right triangle ACP that is coming from the original drawing. According to the Pythagoras theorem, in this right triangle ACP, AC squared equals to AP squared plus PC squared. AC is the missing sign, so electricity, so it is AC squared equals to AP squared. AP is x, therefore AP squared is x squared, plus PC squared. PC is a, therefore PC squared is a squared. So in total, according to equation 1, we found out that AC squared equals to x squared plus a squared. In the next step, we did a construction. That is to say, from this point C, we draw perpendicular on AO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point C and AO. This point is point N. By this construction created here, quadrilateral NCQO. Inside this quadrilateral NCQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle, the total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees inside. So inside the quadrilateral NCQO, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this right angle cut a square. So we relate to this quadrilateral NCQO as a right angle because it has 4 right angles. But we also know that the opposite sides of rectangle are equal to each other. So rectangle NCQO, side OQ must be equal to the opposite side NC. But OQ is 5, therefore NC must be also equal to 5 units in its length. Likewise, according to the sum, in the same rectangle NCQO, side CQ must be equal to the opposite side NO. But CQ is 8, therefore NO must be also equal to 8 units in its length. What is the length of AN? AN equals to AO minus NO. Again, AN equals to AO minus NO. AN equals to AO minus NO. So AN equals to AO. AO is A. AO is B. This is the radius of the quadrant that is B minus NO. NO is A. So in total, AN equals to B minus A. So in the right triangle ANC, AN equals to B minus A. NC equals to 5. AC is the missing side. So I copied the right triangle ANC in the page and implemented the Pythagoras theorem on this right triangle ANC. This is the right triangle ANC. This is a copy from the original drawing according to the Pythagoras theorem in this right triangle ANC. AC squared, that is the square of the hypotenuse, equals to AN squared plus NC squared. AC is the missing sign, so electricity, so AC squared equals to AN squared. AN is B minus A, therefore AN squared is B minus A squared, plus NC squared. NC is 5, therefore NC squared is 25. So in total, according to equation 2, we should find out that AC squared equals to B minus A squared plus 25. But according to equation 1, AC squared equals to X squared plus A squared. So we substitute AC squared here by X squared plus A squared from this equation 1. And finally found out that according to equation 2, X squared, AC squared is X squared plus A squared equals to B squared plus A squared minus 2 times AB plus 25. Here we have A squared on both sides of the equation, so A squared can cancel, so we cancel A squared. In the side of the equation we left only with F squared. On the other side of the equation we have B squared minus 4AB plus 25. So in total, according to equation 2, we should find out that X squared equals to B squared minus 2AB plus 25. In the next step, I copied the right triangle OCQ in the new page and implemented the Pythagoras theorem on this right triangle OCQ. But before that, we implemented here rule 9 because of the fact that those two circles have an internal mass between them at point K. According to rule 9, the third line that connects the circles together passes through their tangent point, that is point K. The center of this circle is at point O. The center of this circle is at point C. And the straight line that connects the circles together is the straight line OC. And according to rule 9, the straight line OC must pass through the tangent point, that is point K, or OCK is one straight line. So CK is the radius of this small circle that is A, OK is the radius of the big quarter circle that is B, so in total OC equals to OK minus CK. So OC equals to OK minus CK. So OC equals to OK. OK is B, it is the radius of the quarter circle that is B, minus CK. CK is A. So in total OC equals to B minus A, everything is the same. So the hypotenuse of the right triangle OCK, OC is B minus A, CQ is A, and QO is 5 units in his left, according to what is given in the question. So this is the right triangle OCQ that according to the original domain, according to the Pythagoras theorem, and this right triangle OCQ, OC squared, that is the square of the hypotenuse, equals to CQ squared plus QO squared. OC is B minus A, therefore OC squared is B minus A squared, and it is equals to CQ squared. CQ is A, therefore CQ squared is A squared, plus QO squared. QO is 5, therefore QO squared is 5 squared, that is 25. So in total, according to equation 3, we shall find out that B minus A squared equals to A squared plus 25. We open the brackets here, and we shall find out that B minus A squared equals to B squared plus A squared minus 2AB, and it is equals to A squared plus 25. Here we have A squared on both sides of the equation, so A squared will get cancelled. After cancelled A squared, in the side of the equation we have to leave B squared minus 2AB. In the other side of the equation we have to leave 25. So in total, according to equation 3, we shall find out that B squared minus 2AB equals to 25. This is according to equation 3, but according to equation 2, we only found out that x squared equals to B squared minus 2AB plus 25. According to equation 3, B squared minus 2AB equals to 25. Therefore, we can substitute B squared minus 2AB here by 25. We did it, and we found out that according to equation 2, x squared equals to B squared minus 2AB, that is 25, plus 25. So in total, x squared equals to 25 plus 25, that is 50. So x squared equals to 50. Let's go out of this equation, and we found out that x equals to the square root of 50. So x equals to the square root of 50. 50 is 2 times 25, and the square root of 25 is 5. So in total, this expression equals to 5 times square root of 2. In terms of numbers, 5 times square root of 2 is 7.071 units. So in total, we found out that the length of descendant AP is equals to either 5 times square root of 2 units in its length. In terms of numbers, the length of descendant AP is equals to x is equal to 7.071 units in its length. Okay, thank you very much.